Welcome to this Rock and Talk seminar on materials and structures for the African framework, which is going to be presented to you by my colleague Nonkululeko Radebe and myself, Wolfram Schmidt. And we are going to talk about challenges, innovation potentials, and research requirements with a focus on sub-Saharan Africa and the African continent in general, which is one out of a series of different regional papers which were presented in Rilem technical letters. Today we are going to elaborate a little bit more than we presented in the Rilem technical letters, but this one you can see on, if you click on the link here on the bottom right. It's the first out of a series of regional papers. The upcoming papers are on South America and Europe. But if you're in sub-Saharan Africa and you're interested in linking your educational or research and science activities with Rilem activities, please do not hesitate to contact me. Because I'm the Rilem Sub-Saharan African convener in the Development Advisory Committee.
Hello, my name is Nonkululeko Radebe, and I am the Sub-Saharan African representative on the newly formed Rilem Youth Council. So this was a council formed back in 2020, which has 10 young members from all the different regions in the world. And what we aim to do is to encourage young researchers within construction to build professional networks and also engage with more established researchers within the field. If you're interested in knowing what we do and what kind of activities you can participate in within Rilem as a youth member, please follow us on Instagram, and also you can contact me directly. So we're going to start off this presentation and talk about the specific challenges within the built environment, specifically for Africa. And as we know, there are many, many challenges. We can list them all. And here we see traffic infrastructure, supply infrastructure, you have connectivity issues between rural areas and urban areas, or even within urban areas. You have urbanization, you have natural hazards, you also have pollution, you have also all kinds of climatic changes that are happening now, even with global warming, and you also have insufficient funding, which depend mostly on global markets. But all of these are all encompassing, and they all add to the issues that we find within urbanization. Most people live in rural areas, so about 60% of the population are currently within rural areas, and about 40% live in urban areas. And it's projected that African cities are growing at twice the rate as rural regions. And on average, when you're looking at sub-Saharan Africa, the growth rate is about 4%. So urbanization will continue to happen, mainly because people are looking for better livelihoods. It also lowers the poverty gap, and you have an increase in service sectors. So here you have a graph that's looking at the relative population between the 1960s and now. And what you see is that the urban population of the world is relatively slow, or slower than what is expected for sub-Saharan Africa now and moving on into the future. So here what we see is, at the moment, if you're looking at the 20 most populated cities in the world, most of them are based in Asia, or let's say China, and then you have some in South America and the Americas. You also have Nigeria and Egypt on the list. But when you're looking in the future, so in the year 2100, most of the most populated cities in the world will be based on the African continent and in Asia, as we see here. And also, if you're thinking about how much this population growth will happen, here we have the list of the most populated cities that will be in the future, and 13 out of 20 of the most populated cities will be based in Africa. Over here we have Lagos, Kinshasa, and Dar es Salaam, all predicted around in the 80 million mark, which is extremely unprecedented dimension for urban areas. And of these, in these cities, if you're thinking about the buildings that need to be built within this space, only 20% of them have been built at this point. So that means there's a chance for 80% of more construction that's going to happen between now and the year 2050. And with all of this comes all kinds of requirements and more challenges, but more than anything, in order to build and in order to house people and to create all this infrastructure that's needed, you need resources. And here we see all the different types of resources that go into this. And with this, you need different supply chains, right? Although Africa has plenty of oil, it doesn't have any chemical industry or much chemical industry. So what happens is we mine the oil, send it out, and then we purchase it back. Similarly, there's hardly any steel production that occurs on the continent. And also we have a lower occurrence of fly ash material. And on top of all of this, we have more issues such as traffic. So over here you have Accra, Lagos, and Cameroon. These are very vastly different cities, but they all experience similar issues when it comes to traffic. Although the issues are based on different things. For example, in Accra, you have a limited number of junctions. And then in Douala, you have a lack of traffic axes. And then in Lagos, although there are many roads, so there are different layers even of roads, but you always have roadblocks on all different layers. So this is one problem that you can see in all different cities, but at different scales. And then we also have the issue of socio-economic challenges. So about 60% of Africans live in neglected and non-formalized settlements. And with the least amount being in Zimbabwe with about 18%, but in South Sudan, it's about 96% of people that live in neglected settlements. So these are also other challenges, these socio-economic challenges. And on top of this, people are looking for better livelihoods. So there's a really major demand for construction materials, which will then create better livelihoods for people. And on top of this, we have environmental issues as well. And in more than any other parts of the world, construction is what is going to develop the African continent in a more sustainable way, though, because it's mandatory for this to be sustainable for the population, for social rest, for economic development, to protect the environment, and as well as to not contribute so much to climate change. So now that we've covered all the different challenges, I think we can move on to more of the potentials within looking at specifically materials and the structures. So this is probably my favorite graph that shows the carbon footprint of the world. So you have here the United States, which is it has a carbon footprint at the moment of about 16.5 in 2018 per capita of CO2 emissions, compared to 0.8 of sub-Saharan Africa, which means at the moment Africa is barely contributing to the carbon footprint. It has a very low carbon footprint, and it's also below this threshold that will reach the 2-degree increase in global warming. So really, Africa is at the helm, and it can really be a role model for many of the other more developed countries when it comes to sustainable urbanization. So this is a huge potential. And we've got several degrees of freedom. So if you consider Europe, for example, it has an extremely regulated industry when it comes to construction, which is the opposite actually in Africa. Maybe, of course, we can do with a little more regulation, a little more reasonable regulation, but having lower standards will increase the innovation potential that we have compared to Europe, for example. And as we know, we have an abundance of resources, like many things that come naturally within the African continent, and we can really harness this to grow. And of course, we also have growing markets. Despite the pandemic in the past 2 years, this is still a positive thing, and this continues to happen.
Yes, and with all these innovation potentials that are on the table, it is possible for researchers and investors and the industry in Africa to develop novel concepts which are more future-oriented which are more holistic, where materials are considered as a unity with the structures and the environment and the society. Basically, that's something where the Globe Consensus, where also Rilem is involved, is aiming at, to create this more holistic view on the entire built environment. And I think people in Africa can really become a great contribution and a role model for future-oriented construction. But this starts with materials. And here, if we think about urbanization, we have a few materials on the table which could be used: earth materials, timber, steel, and concrete. And there's a lot of kind of religious discussion which material is the best. Maybe this can be discussed based on this figure. This figure is quite beautiful because it shows the embodied carbon for different materials on the ordinate and the embodied energy on the abscissa. And we can see plastics are here, steel is here, timber is here, cement can be found here, and concrete is always on the lower end of the axis. If we would replace concrete with different other materials, we would not make the situation better. But normally, if you purchase a house, you don't say, you don't go to the market and say, I'm going to purchase 15 tons of house, maybe which are a mix of steel and concrete. Normally, you buy a house in volume, so walls and all the structural elements are in volume. So if you relate the global warming potential, for example, on volumes, maybe that would be a more reasonable assessment. But then again, the numbers for steel would be awkwardly high, which is also not fair to this material, because steel has outstanding structural properties and you don't use it in order to fill a volume. You just use it because of its outstanding load-bearing capacity. So it could certainly also relate the global warming potential on the load-bearing capacity, which is relevant for each material, which might be an option as well. But then materials which have a really low carbon footprint, like rammed earth, for example, or earth-based materials, would all of a sudden get a very high global warming potential. But normally you don't use these materials in order to have a high strength. They have different strengths, for example. So that indicates that it's very challenging to find the right assessment. What is a sustainable material? And maybe it's better to diversify the discussion. All materials have their pros and cons. For example, timber have a apparently relatively low carbon footprint, even if this can be discussed. But on the other hand side, if we look at particularly the African continent, where many countries suffer a lot from deforestation already, this really has to be critically discussed whether timber is the right material for urbanization in Africa. Then steel certainly has a dramatically high carbon footprint, but it has some outstanding tensile strength properties which cannot be compensated by other materials. So it has to be used. And earth-based materials have a super low carbon footprint if it's not mixed with a cementitious binder. But the problem is the maintenance need. So here you always have to find a very good balance. And eventually we have to look at concrete. It has a big advantage. It is doable everywhere, but particularly in many African countries, in many African cities, you don't find the application technology available, which would be required to really make use of the best concrete technology. And certainly you also have to consider a balance between the global availability, which is certainly there, but also the price situation. And just to underpin this, for example, if you would take an average German income earner and would let this person start to work on the 1st of January, in order to purchase a ton of cement, this person would only have to work from 8 o'clock in the morning to lunchtime, while in the Democratic Republic of Congo, in order to purchase the same ton of cement, an average income earner would have to earn from the 1st January to the 20th of November. So if you express cement prices and purchasing power, all of a sudden you see how dramatically higher the cement prices are in Africa. So what we can see is all these materials have their pros and cons, and there is not a simple solution to assess a material, not a single solution particularly. And unfortunately, there's also no marvel solution for this planet. But I think one conclusion we can draw from here is, as all materials have different strengths and weaknesses, we have to think much more in a hybrid way to combine materials according to their specific strengths. And this is something where Africa can become a green construction pioneer, because hybrid construction has already been established in the local architecture quite many times, like, for example, on the bottom left, this is in Zanzibar, in the East African architecture, you will find a lot of hybrid elements. And then if we want to really build sustainably, we have to avoid architecture that is materials wasting, like structures like this one without any pillars or towers, which are incredibly high. They are just wasting materials, no matter which kind of material we are using. If you look at the vertical structural elements that are required for 50 stories when you would stack them upon each other, or when you would horizontally disperse them, you would require 25.5 times more materials for the vertical elements for the stacked structure in comparison to the horizontally dispersed structures. We do not even consider that the higher you build, we are having wind loads in addition, and we also would require more materials for the foundations. Then the same applies also for the span widths of girders, for example. If you want to just have a span width of 5 meters, you could work with much smaller girder heights. And the global warming potential in comparison to a 20-meter span width, where you would require a significantly higher cross sections, would be significantly lower. So sometimes a single pillar in between can help us save a lot of materials. Even if we require an additional pillar, we would save a lot of materials here. And we also cannot overcompensate this by just using higher strength concrete, for example. Normally, you will always find, if you do a measurement or a dimensioning according to the Eurocode, for example, here, you can find that there's always an optimum cross-sectional height, and normally the lowest global warming potential can be found rather in the lower strength concrete area. African building codes could really show the rest of the world that there's a better way to do that. And then certainly it's very important to build with an architecture that is sustainable in itself, so that we don't build buildings which 10 years later no one wants to see anymore. So here we are talking about the longevity of architecture, but we also have to talk about the longevity of structures themselves. Today we all dream of automated processing, where robots take over control of the calculations, of the casting, of the processing in general, and the human component, we can see, becomes very small. I don't want to criticize that in general, but we also have to see that certainly the structures that are built here are all very, very perfect, but probably cold because that human component is missing. If I compare this, for example, with a structure like the Great Mosque in Casablanca, where you can see a lot of crafted works which was done by artisans from all over the Moroccan country, we have to see that probably this spirit, this love, and this human factor that was incorporated into the structure might be much more sustainable on the long run. We still will like this in 500, 600, or 700 years, even though it is not probably perfect. Maybe it's because it's beautifully imperfect. And then when we talk about aesthetics, we also have to see that Africa can become a spearhead in bringing the structures that we are building more into the society. You will find a lot of places like in South Africa, like in Nigeria, like in Ghana, where some of these examples are from, where structures are used to bring beauty into the center of the urban living. And I think this is something which is very simple to create sustainability, but which is something where the rest of the world can really learn something about sustainability. And this has traditionally been used often for many, many centuries. And this is another aspect which can become an important component of African future developments in urban construction, to reconsider vernacular techniques, because arches and shell structures have been traditionally established in many, many regions in Africa. And we all know that these structures have a very good and gentle load carrying behavior, where the momentum is relatively small and also tensile loads are minimized, and we have mostly compressive loads, which are very good for the vernacular materials that have been used at the time. So all these structures have already been gone through a research process over generations and have proven to work very well. The same also applies for structures which are using natural materials, which are certainly coming from the region, and therefore they are already sustainable in itself. And also some very elegant ways of structural design for roofs, for example, like in these South African rondavels, where you don't require a pillar in the center, and you also minimize the horizontal loads that are applied on the brickwork. And we do not have to discuss whether this is technologically sound or not. We have a lot of good examples from past structures, some of them not only centuries, but even millennia ago, which still obviously sustain all the environmental stress they are getting. So looking at vernacular structures is something which is very future oriented, and Africa has a long tradition which can really show us the future of construction more. But we certainly have to also not only understand the vernacular structures, but we also have to develop it further. This is what in the Rilem technical letters we call vernacular 2.0. We have to use modern analytics, modern knowledge in order to enhance these materials without giving up on their natural concept. And this, for example, is something where we can use vernacular structures. We can certainly use a steel reinforced concrete skeleton for structure, but we can fill it with vernacular materials. That would be a very good approach towards sustainability. We have to also talk about concrete. Many people don't like concrete. I'm not one of them. I love it, but we have to consider, if we look at the different materials, that concrete is the only material that we have sufficiently available on Earth to meet the global demand for construction. So concrete is there, and concrete will also be something that will coin urban construction technologies in Africa in the future. Cities will require concrete, no matter whether people like it or not. We don't have an alternative for concrete, but certainly greener concrete, better concrete, where we use more sustainable cement types and binders, where we use better concrete, and where we also use less cement in concrete, where the entire concept undergoes a mindset change and a paradigm change. And how can we get there? And we try, in order to reduce the carbon emissions, we try to avoid the Portland cement as much as possible and replace it by supplementary cementitious materials. And in order to tickle out more efficiency of the binder, we try to reduce the water-cement ratio. And here we require chemical admixtures. And resources which we often not look at very intensively are bio-based resources in order to obtain these supplementary cementitious materials, but also the polymers for the chemical admixtures. And this is something where Africa has a very strong potential, because 60% of the unused arable land areas of this planet are located on the African continent. And then we certainly have to make sure that this all happens in a circular way, that the value chains and the supply are connected on the short distance and create livelihoods and circles. Here's an overview for different countries in Africa, how much of the total country's maximum cement production capacity can be replaced by the most often occurring plants: cassava, maize, rice husks, and groundnut ashes here. And we can see that the percentages are relatively low for quite some countries. For others, they are higher, 3, 4, 5%, up to 6%. This, in comparison to, for example, to fly ashes or to ground granulated blast furnace slag, sounds a little bit small, although it is, let's say, 1/3 of the global availability of these materials. But we have to see that the total cement production capacity is typically 2 to 3 times higher than the real cement production capacity. You also have to consider that in most African regions, the hectare yield of plants is relatively low, and it could be at least doubled. Then we also have to consider that the population is growing, and agricultural production and population growth are correlating one-on-one. And then we also have to consider this additional arable land which is available all over the African continent. So if we just multiply this, we can create a growth potential for these numbers of 1,600%. And then all of a sudden, the availability of these resources is much greater than the availability of fly ashes or ground granulated blast furnace slags, which we're using today. And that creates a very good situation, because now the local bio-based materials contribute not only to lower carbon emissions, but they also reduce the price for cement. So instead of looking only at the cement producers to reduce the carbon emissions, we also have to look at the responsibility of the small concrete producers, the tire producers, and also construction chemical companies to do that. And just to show you which potentials are there in Africa, here's just a short case study for concrete, which is made of cassava waste. It's an important plant, and today cassava is being harvested. It's the tuber that grows under the earth, and it has a very thick peel, which is cut off, and then the inner part of the tuber is converted into a food product. What happens? It produces a lot of waste. And this waste is not digestible for animals. So it's a real waste which doesn't have a value. People typically just dump it away, where it starts to stink, it attracts insects, it requires a lot of space, and it doesn't produce any added value. But instead of considering it as a waste, we can also use it as a resource, of which we can obtain first an organic component, which has plasticizing properties. So cassava starch has properties to reduce the water in concrete. Then we can still use the residues of that and use it as a co-fuel, for example, in the brick production process. And eventually the ashes, after burning them, have pozzolanic properties. So we can use them to reduce clinker content in cement, or we can use it to reduce the cement in concrete. So with this way, from something which formerly didn't have an additional value chain, we can create two non-competing value chains, one in the chemical industry and one in the construction materials industry, and in between we can also create energy. So we use the wastes entirely, we minimize the carbon emissions if we use the right technology, which is sketched here on the top right. We use renewable resources. We have a tremendous circularity potential also between rural areas and urban areas, and it creates new employment. And that it works, we have recently proven on the campus of the University of Lagos, together with my colleague, Dr. Kolawole Olonade. We are currently building a house which is made of concrete, which is based on cassava wastes. This was awarded the German African Innovation Incentive Award, and this gives us the opportunity to really bring this into real life, to make it tangible to the people.
We've now identified all the challenges, and Wolfram spoke well now about all the different potentials and even went into the different types of materials that are already being used and can be used in the future. And now we look to what does the future look like? The point is we have a diversity in the types of cities, and we also have a diversity in the ways in which these cities will grow. But the factor is they will grow. And over here, we have what we show as different starting positions. So I just showed you the two cities like in Dar es Salaam and Lilongwe. The one currently is already semi-high density, and we would say Lilongwe is more low density. And this means they have different limitations when it comes to growth and different degrees of freedom. But I won't expand too much on this, and you can find this in the article that's on the bottom left-hand side, if you are interested in knowing more of these degrees of freedom and the limitations. And this was an interesting kind of interview with young kids, some kids based in Nairobi, so in the Makuri estates in Kenya, in part of an initiative called the Star Kids Initiative run by Esther Kamara. And the kids here looked more to when they were asked about what their future looks like, or what the types of cities they would like to live in, or places rather, they wanted more space, more greenery, more animals. And this is a rather more rural wish for kids who live in the city. And then you have some girls and young women that are in Bagamoyo, in Tanzania, a program run by Faudia and Vincent, the Forward Step organization. And the kids here wanted something different. They wanted shorter distances to travel. They wanted more health and service facilities and more educational institutions, which is a rather more an urban wish. So basically there's a difference in a diversity in the types of cities that people want to live with and within. We have to then consider how to make cities more robust and to fit the futures in which the people who live in it right now would like it to look like. And within this framework, we're always talking about, okay, what does sustainability look like, and we make it extremely complicated. But within the Falconers program, we've come up with something called the 10 Golden Rules for Sustainable Urban Development. And these can be applied in any city, anywhere in the world. If you're looking at sustainability, you can look at what types of environment it is, the technology, economic, society, and the institutions that are within. So for example, if you look at the environment, is the environment healthy for its inhabitant? This is a yes or no question, and this can be answered in any city, in any place in the world. Is it equitable? Is it does it have future prospects for its people? And does it leverage the regional growth? And this can be a yes or no question as well. So if you want to find out more about these golden rules, you can visit the website www.falconers.org. It also has a more expanded version of each of these factors, but the point is it doesn't have to be complicated. And within all of this, many of us are researchers, and we are currently, looking at different things like materials and structures and so forth. And now we want to know, okay, what types of research or what is required for this future? What is required for these potentials to be fully harnessed? And basically, it requires interdisciplinary research. So we've spoken about materials, we've spoken a little bit about the construction technology and not so much on the maintenance, but these are the three sort of main topics when you're looking at construction, not only in Africa, but in general. And all of these have an interlink. So if you're looking at the materials, have a direct link into the types of construction that you can do and how it can be maintained, for example, in the future. And all of the people within these different fields kind of have to connect, not kind of, but have to, it's a need. So the fact that somebody out there is looking at LC3 materials, it has a direct implication on durability or maintenance and different circular economies that can be built using those materials in other places. So it requires interdisciplinary research. So here we've reached the summary and the outlooks, but in general, what we can say is that we cannot move on with what we call business as usual. We need to create different frameworks, more sustainable frameworks, more value chains, because the opportunity is there. These do exist. And I want to emphasize that even when you're looking at solutions for specific problems, these are always case-specific solutions. So we want to know what material to use, which structures, which technologies. And of course, you can answer it in general, but it has to work for the set purpose. And with that, I'd like to come to an end with this. Thank you so much for listening to us. And if you would like to know more and engage with us, please contact us. That's our email address.